This is the part 7 of a tutorial where you are designing and building this keyboard. In this video, we are going to manufacture and buy everything we need to finally build our keyboard. If you haven't watched the previous parts of this tutorial, links are in the description. Let's start. Go to Tools, Copper Manager. Be sure you rebuild all the coppers. Also, rebuild the ground planes on layer 2 and layer 3. And double check the DRC. All this is really needed before generating the output for the manufacturing. Now go to Export and PCB fabrication files. We are going to generate Gerber files. These are the most important files. We already checked the DRC. And these are the files what we have generated. I'm going to create new directory and I'm going to copy all these Gerber files inside of this directory. We would like to check them before we send them to production. So what is inside of these files? To see what is there, I'm going to use this free ViewMate viewer. You can download it, it's free. This one here. Download and install it. It looks like this. And here I'm going to import all the Gerber files what we have just generated. I'm going to copy the path to our project. And these are the files which will be used to manufacture your PCB. All these Gerber files, select them and import. Now click on this empty layer and we would like to also import drill file. These are the drill files. Import. Drill files are again for PCB manufacturing, and based on drill files they will know where the holes are located. Just go through every single layer and double check how it looks. Okay, so this is the seal screen layer. Double check the text. You don't want to have mistake in text on seal screen layer. Next is the mask or paste mask. So that's the solder on top layer. This is the top layer. If you need, you can change the colors because then you can very easily double check the places where two layers are above of each other. It's very useful. As you can see, the solder is correctly placed on these SMD pads. Okay, this is the inner layer, and I'm going to change the color because that's the outline. And these are the places what I was talking about. When you place vias very close to each other, they will cut through the copper, but it's okay. These cuts what we have here, they are very small. Everything looks fine. The layer 2 and layer 3, they are exactly the same. Drill drawing. Oh, this is not really important. This is also not very important. Solder mask, bottom solder mask. So these are all the openings around the pads, and I would like to see it together with the solder paste layer. Paste is only on the pads where the SMD components are placed. Mounting holes and the logo, they don't have the solder. See? Very important. Otherwise your logo would not be gold if you put solder there. Through hole pins, they don't have solder. This is the bottom layer. Okay, everything looks good. Double check also the seal screen. Again, you don't want to have any mistakes in seal screen. Maybe we would like to flip this because we would like to see this correctly. Okay. Perfect. Double check if there are no mistakes. I hope there are no mistakes. That would be very embarrassing. And now the holes. I'm going to change color so we can see it better. So these are the via holes, plated through hole, okay, and non-plated. These are around the switches. Non-plated, it means there is no copper inside of the holes. Perfect. So it looks good. I'm going to copy this zip file inside of our directory used for manufacturing. Now we are going to generate BOM, bill of material. And you can use exactly same settings what I have here and check all these what I'm using. Here are the parameters what I'm using. Generate the BOM. Here it is. And we are going to double check what is inside. I will delete this first because this is the directory which we just used to check the Gerber files. Now open the BOM, bill of material, and there are all the components which are in our PCB, which are on top and bottom layer. And for assembly, we only would like to use the bottom layer. We are not going to do assembly in JLC PCB for top layer. We will do it manually. So delete all these components which are placed on the top layer. I'm going to change the numbers. Okay. And double check these. Okay, so save as, and I'm going to call this assembly bottom. So this is the file what we will use when we will be manufacturing our PCBs. Okay. Next, we would like to generate pick and place file. This has information about the position of the components in our PCB. Use exactly same settings, same export. Here is the file. I'm going to copy it into our manufacturing directory. And again, we would like to remove some of the components. Okay, this is the position of every component in our PCB. And I'm going to remove all the components which we don't want to have in BOM. So select all these with no for add into BOM. These are the unfitted components. From the bill of material, these unfitted components were removed automatically, but from this we need to remove it manually. I'm just very careful, I don't want to make any mistake. Okay, double checking. Okay, I can delete all these. And also I would like to delete all the components which are on top layer. So keep all the bottom layer components here in the list and select all the components which are on the top layer or top side of our PCB. Again, I don't want to make mistakes, so I'm very careful. Remove also these. Okay. Double checking. We can delete them. And now we can save the file. Again, I'm going to call it assembly bottom. Save. Close. Okay, so this is the file what we will use for assembly. Save everything. Now go to JLC PCB website. Click here, instant quote, and we are going to upload these files to the website. So I'm going to copy this path and gerber files and select the zip file. These are the gerber files, okay? The files needed to manufacture the PCB. Okay, it looks like our PCB. That's good. Now, double check all the parameters. Most of them we can keep them default. Here I would like to maybe use purple. And surface finish, we would like to use any because that's the goal, but it influences the price. Watch. It will be more expensive, but the logo will be gold. Layer sequence. Yeah, maybe we would like to specify this so they don't make any mistake, but it should be, by default, it should be also correct, but I like to always specify it just to be sure the sequence is correct. Stack up, we would like to use 3313 stack up, so select it. That's the stack up which we use to calculate the impedance and track geometry, or track geometry for specific impedance. Okay. Keep all this. No, I don't want to have mark on PCB. Okay. We would like to do also assembly. Only the bottom side. And yes, please confirm placement. They will send you email to confirm the placement. You really would like to see if all the components are placed correctly. And we can keep all these default. Everything is okay. Check. Next. Next. Now we are going to add the bill of material. So assembly bottom, BOM, and this is the pick and place. Again, assembly bottom, pick and place. And click here. This is very interesting moment. Two parts are not available. Only two parts. That's good. Okay, let's stay positive. So the crystal, they don't have the crystal and the sockets. We will need to solder down these manually, but they have everything else. So that's really, really good. Next. Okay, do not place the parts which they don't have. Confirm. And this is sometimes a little bit stuck, so we don't really need to wait. Next. And here are the prices. So this is for the PCB, 50. It's for 5 boards, okay? And this is for the assembly, 94. So there is setup fee, stencil, and then that's the component cost. Here we need to put a description. I think this is mostly for customs. When they ship it to you, then they need to fill out this information. And you can double check the order. So, for example, we can double check the gerber files before paying and before the final order. You can check the gerber files directly. Here are all the layers. I can disable all the layers. We can just double check them, be sure everything is correct. Everything what we uploaded for manufacturing is correct. You can also double check the layer order. Here you can very nicely see, okay, top layer, layer 2, layer 3, and the bottom layer. Everything seems to be fine. Okay, so we can close this. And BOM, here you can see what components will not be fitted. So it's then very helpful because you know which components you need to order by yourself. Now let's do 3D printing. So here we are going to upload the simple enclosure which we generated from EasyEDA. And even if you have 3D printer at home, try this. I recommend you to try this because the quality between industrial 3D printing and home 3D printing is very different. Industrial 3D printed products are very, very nice. Again, I think this is for customs, so we need to fill out something. Use same material, okay? Or you can experiment, you can try different materials. But I use this image in black. And also we would like to 3D print the bottom part of our box. And I'm going to use exactly same settings, so image in black. And description. It's not very expensive, you can see it's like $5. Okay. Perfect. So you can see we have one order for PCB and assembly, and we have 2 orders for 3D printing. Here are all of them listed. And here you can also double check if this is the enclosure what we would like to 3D print. That's the correct one. Is this one with the hole? Yeah, this one is with the hole. Perfect. Now, if you would like to try, you can go to my Thingiverse or to my GitHub, and you can download extra enclosure which I created for this keyboard. So go here. A picture may be a little bit different because I will change it once I have the finished enclosure. And I uploaded all the files here. This enclosure is a little bit different. You can see this is how it looks. And if you like, you can 3D print also this one. Actually, I like it a lot, especially the color 3D printed one is beautiful. This is the metal plate for the buttons. And this is a picture for the color 3D printed enclosure. This is how it actually looks. Okay, these are all the parts what you need to build the keyboard. Okay. Here are also the knobs for the encoders. You can download them and 3D print them. I'm going to show you what everything you need to 3D print and how. So download these files, all of them. These are the files. And let's copy them to our manufacturing directory. So for all boxes, we need the knobs. So even if you are 3D printing the enclosure from EasyEDA, you still need the knobs. So these are all the files what you need to 3D print the knobs. And also you need the plate. You can CNC the metal plate for the buttons, or because it's a little bit more expensive, you can also 3D print it. It's no problem. I created models for both variants. So first, the knob body. This is the main body of the knob. And this is how it looks. I'm going to use again this image in black. And I'm building actually 2 enclosures, so I would like to have 6 of these. And we need to put description. And also this is the top for the knob. So if you would like to use some kind of colors, if you would like to make it nicer, you can 3D print this and then apply color on top of this. So here, use spray painting. I'm going to use glossy, and I'm going to use purple. Again, we need more of them, 3. And then also I will 3D print 3 more. We can duplicate this one or we can upload it again, but I would like to do it in different color. So I'm going to upload the top of the knob, and instead of purple, I'm going to use spray painting glossy black, and 3 of them. Okay, so these are the knobs. Now, this is the plate. So if you don't want to do CNC, you can 3D print the plate for the buttons. This will help to hold the buttons in the place. It doesn't have to be metal, but in this tutorial I also wanted to show you how you can manufacture metal parts. So that's why I included also the CNC variant of the metal plate. Okay, I'm just double checking. We need 2 of these plates, okay, because I'm building 2 keyboards. I forgot something. Description. If you are only building 1, then 1 keyboard, then only use 3 knobs and 1 plate. Okay. Perfect. Now go to CNC, and we would like to order also the metal plate. This time we would like to order it not plastic but from aluminum. Okay, so this is the plate. I'm going to use aluminum, anodized, black, glossy, $18. They have 2 aluminiums, $31. This one is a little bit cheaper, so I'm going to do it again. Anodized, black, glossy, 26. Okay. For 2 pieces, save to card. Okay, now you can see we have 1 item also for the CNC, 6 for 3D printing, and 1 for PCB. Next, what else we need 3D print? So for the special box what I created, there are few additional parts just to make it a little bit nicer. This frame, I'm going to copy it, and these rings. So I'm going to order 3D printing for these. We need to go up, and we would like to order the frame. A little bit later I will show you how you can use these elements, but as I say, these are just to make the box look a little bit nicer. These are small elements which can add nice color to your box. You can print them in different colors. Okay, so if your box is, for example, black, you can print this frame in different colors. And because I'm using the purple galaxy motif, I'm going to print it in purple. Same for the rings. So these rings, they are around the opening for the knobs, and the frame is around the opening where the keys are. We need 3 rings. Again, I'm using purple color. Don't forget to put the description, and this is how it looks. I will simply just glue it there. I use super glue to glue it to the top and bottom, to the top enclosure. Save it. Okay. What else? Top and bottom. box. So this is the special one which I created. You don't have to 3D print this, only if you like it, okay? You can 3D print the simple box which we generated from EasyEDA, but especially the multicolor one is really, really nice. You will see. So this is the better version of the box, but this is not multicolor. This is just one color. Again, I'm going to use the black one, and then you can use different color for the rings and for the frame to make it nicer. And also I would like to upload the bottom part of this box. Okay. Perfect. I made the ribs there because it makes the enclosure a little bit stronger. If the enclosure would be too large, it can bend or something. So that's why I use the ribs. Okay. And now the multicolor enclosure. So this is the one what I recommend you to 3D print. It's a little bit more expensive, but it's beautiful. It's beautiful. And you need more files for this. You need these files, and also you need this picture. So this is the pattern. And if you are using Windows, you can just double click here and it will open the 3D view of the enclosure with the picture applied on the top of this. Okay, so this is how it looks. So if you like, you can only 3D print this one, but as I said, it's going to be a little bit more expensive. You will see. So let's upload this one. This is the top, and a little bit later they will ask you for rest of the files. Here on the website you only can upload the OBJ files, but you will receive an email and they will ask you to upload or send them the other files too. So this is the top, and use the full color multicolor. Okay, surface finish yes, all spraying. Okay, all spraying, it means it will be glossy. But you can see it's $21. So together with the bottom is like, I don't know, almost $50 for the enclosure. But as I said, you can use your own picture, and in the next part I will also show you how you can apply your own picture on the top of the enclosure. So you can create enclosure you really like. $21. Yeah, and the other one was $25. Okay, so one CNC 12 for 3D printing and one for board. Now we would like to order the board, and then we will order the rest of these. Right now I think it's not possible to order everything at once. You will receive it in 2 packages. So first I'm ordering the board. It's very simple. If you like, you can keep all the default settings or default shipping method. Or you can play with different ones. Some of them are cheaper. Now I'm going to order the 3D printing and the CNC. You need to have 13 items selected. You need to check this, okay? Be very careful, otherwise you will not order everything. 13 items. and again go through checkout, but this time continue and submit order. They have to review everything and then you will pay the money. So submit order and let's wait for an email from them. Okay, everything ordered. We will see what will come back. So PCB, and here are the parts for the enclosure. Action required. So I received this email. Check the placement. You remember, we asked them to check the placement. So we need to review the placement, what they are suggesting. Click here. And this is a small view, so click here. And double check if everything is okay. Especially you would like to see like pin number ones, diode rotation, and these kind of things. You can also see these slots are not fitted. These are the LEDs. Okay, looks like they are fitted correctly. Pin number one. Connector or header is not fitted. And pin number one for microcontroller, flash. Crystal is not fitted because they didn't have it in stock. Everything looks okay, so we can confirm. Okay, you will also receive this email. This is about the 3D printing. And in my email, they are saying also something about these walls. I will correct this, okay? So you should not receive this kind of problem. But they are also asking for the missing files for the multicolor 3D printing. So we would like to send them these files. Okay, I will correct this. And I'm going to attach the files. So pack all these and attach the files to the email. This is how you 3D print the multicolor enclosure. They need these files. Send. Okay. Now refresh, and there will be few more questions, I think. Here, for example, 0.8. Okay, you will need to confirm that there are some very thin parts. This is the multicolor 3D printing. And here, what is here? Again, small. Some of the parts are a little bit smaller, but it's okay. Yes, check. And okay, so these are the steps how you can order the PCBs, the boards, and the enclosure. Now, I still need to order these missing parts. So I'm going to find this crystal in Farnell. If you have any missing parts, you also need to buy them, okay? So don't forget to buy these missing components before you receive the boards from production. So once you receive the boards, you can just solder it and test your boards. Okay. And these are the slots. I bought them on Amazon. Just search for this number, like this. This is the manufacturer. I'm going to add the manufacturer. Okay, I think these are the slots what I bought. 50 pieces. This is how it looks. Buy them. Okay, and also what else we need to order, do you know? There are few more components, the components which are on the top. So open the bill of material and find the components which are on the top. This one. These are the encoders. So we would like to buy the encoders. I will use Mauser because I know they have them here. We need 3 of them, of course. If you are not sure how many you need, you can always double check in BOM, bill of material. Next, this one. So this is the RGB LED. And I'm going to try to find it. This is not RGB LED. So I'm just going to find N or A LED, RGB LED in the same size, same or similar footprint. This one is, I think it was 1 by 1 millimeter. Yeah, 1 by 1 millimeter. So I'm going to find something similar. 1 by 1. Let's say this one. We need to double check the datasheet. If they are compatible. Especially pins. I would like to see the pins. Okay, compare pin number 1, and it's the common anode. Pin number 2 is the red, 3 is green, and 4 blue. Okay, buy 1, or if you are building 5 boards, then buy 5 of them, but I'm going to buy only 1. Okay, next, green LED. So again, we can copy and find it. Okay, they don't have it, so I'm going to find something similar. You can basically use any LED because, you know, it's 0805 footprint. There are many different LEDs. Usually what is different, what may be different is the intensity. So maybe you can play with the resistor value, but you should not have any problems to find 0805 green LED. I'm going to find the one which is in stock. For example, this one. Minimum 5 pieces. And I would like to use maybe same manufacturer, but the yellow one. here I'm going to select yellow. And maybe this. Okay. What else we need to buy? Standoff. Okay. So see, now we can directly use the supplier part number to find these standoffs. This is the information which we placed inside of the symbol when we were creating it. We need 4 for one board or 20 for 5 boards. And the switches. Okay, I know Mouser has the MX cherry switches. These are the switches what I would like to use, the MX cherry red, this one, RGB, so it's transparent, so the light from our LED goes through the switch. And you need 9 for one keyboard, but I recommend you to buy a little bit more in case you bend the pins. It may happen, so buy some extra switches. Okay, these are all from this list. But do you remember in schematic I placed this list, what everything you need to build this keyboard. These are the parts what we 3D printed, and I'm going to show you how you build the keyboard, okay? So this is the PCB. Then you add the metal plate. This is the bottom part. This is the top part. So plate, bottom, top. Now encoder knobs, frame around the encoders, encoder knob top, and frame for buttons. So these are the knobs, these are the rings, and this is the frame. Okay. You also need this transparent filament, which you will put inside of these holes to bring the light from the LEDs to the top of the box. And you need also these. Okay, so keycaps, you can, for example, buy them in Mouser. Keycaps are these. You need to place them on the top of the switches, and they have many different types. This is the one what I used, but they have also different colors and different shape. Then you may want to buy the feet and screws and the super glue. So these are the feet. It's just an example. They have many different feet. You place them on the bottom. You can place them over the holes for the screws, so keyboard doesn't move on your table. These are the screws, but these they have a little bit weird head, so you may need like special screwdriver. I use this one, and also you need these screws to hold the metal plate. Okay, so these are the 4 screws for the case, and there are 4 screws to hold the metal plate. You need 8 screws in total. They are different screws. Go through the list in the schematic. And this is the glue what I use. Gorilla Glue, super glue. This is very useful. It's not expensive to buy, so buy it. It will help you to remove the switches and keycaps. It's very helpful. Okay, so don't forget to double check if you have everything. I received another email. Everything is now okay. We just need to pay for the 3D printing and CNC. So I'm going to refresh. and there is the pay button. So let's pay. Okay, I use PayPal. Pay. Okay, everything seems to be fine. Now, I recommend you to create this new version so you know exactly which schematic and which PCB you send to production in case you need to go back to this specific version. Okay? You can see, you can always go back and open this version. It's very useful and very important. All these files I uploaded to my GitHub. So just search for Fedevel GitHub, custom keyboard, and you will find them here, okay? So in case you need any file which I used in this video, you will find everything here. You can import the file, the EasyEDA file, directly into your EasyEDA in case you need. Here are the documents which we used and 3D models which we used. Here you will find software. This is what you need, that's the firmware. This is for VIA, and this is for QMK. And if you go here, and when you search my name, then in users, my projects, or projects, I don't know how exactly you will see it, this project will be available, and you can directly clone whole project, and you can just reuse this project or build on top of this project your own keyboard. Okay, just open it in the editor and you will see the whole project what we were creating in this tutorial. And don't forget, on my Thingiverse you can also find all the all these 3D models, in case you would like to see the 3D view, because in GitHub you don't see the 3D view of the models. Here you will find it, okay? In case you are very quick and you receive your board before I release the next part of this tutorial, connect your board to your PC, double click on reset button. Now, download the files from the GitHub, here they are, and inside of the software these are the files which we will need. This is our keyboard, Raspberry Pi USB storage, and copy this UF2 file on your keyboard. This is the firmware update. Now, if you would like to customize the shortcuts, search for VIA keyboard, go on this website, click here. First, we need to load the layout of our keyboard. So here, click on load, use this JSON file, watch down here, you will see new keyboard, custom Fedevel macro board, that's our keyboard. Now, click authorize new and select your keyboard, connect. Now you can just select a key and then select the shortcut. That's it, that's how simple it is. Or select the encoder and select shortcut. Here you can set the color of the LEDs, and that's it. That's basically how you use the keyboard. Save everything. What now? Now you need to wait. Once you receive everything, build your keyboard. Just follow the instructions that I explained by the end of this video. I still would like to make some follow-up videos, especially to cover keyboard building, customizing the software, and applying your own image on the top of the case. So check the links in the description. And don't forget, if you would like to learn more about electronics, check out our online courses about schematic design, PCB layout, EMC, measurement. We have courses about KeyCAD, Altium Designer, and more. Go to fedevel.com and have a look. I hope you enjoyed this tutorial and thank you very much for watching. See you in the next video. Bye!